All right, let's learn about the immune system. All right, before we start, I want you to do a couple of questions. Identify 3 specific signs that your immune system is working, and I want you to explain how you know these signs are immune related and why they occur. So just a couple of sentences there. Pathogens are considered microorganisms that invade our body and cause illness. Now, we know that they can be bacteria, viruses, parasites, yeasts, all those kinds of things. There's a huge range of them. An antigen, however, comes with that microorganism, and an antigen is a foreign substance on the surface of that invader. It's often a protein, and that's what our body is reacting to. Okay? Our body is saying, that's not us. That is not a self cell. That is something else going on, right? And that is what triggers that response. So they are considered harmful. And so even if you have a blood transfusion or something like that, we are considering those cells where the proteins don't match harmful. They are antigens that we react to. So if you have an open wound, something's going to jump in. And as we spoke about just then, on the red cells, we even have antigens. So even if they are normal human cells, there's still proteins there to say, hey, this isn't us. We're going to talk about 3 lines of defense. First, second, and that final. And that is a specific line of defense. Our first 2 are non-specific. They're trying to kill everything there, right? We've got the big atom bomb to say, hey, just trying to get rid of everything, as opposed to the more specific there. Woo, clip art. Right, would like you to now do something before we start. Discuss why the body has both a non-specific and a specific line of defense by comparing and contrasting them. Our first line of defense is all about physical and chemical barriers. It is firstly talking about the things that we actually just prevent. We're not going to build a wall, but we are trying to keep things out. We're trying to prevent entry to our vital organs, right, including our brain, our heart, all those things. So our number 1 is that our skin, right? That's our main one that we think about. We do actually have ability to kill pathogens that may enter the body right at that very first level. So if we're talking about our skin, we've got a massive covering. Obviously, we need a few openings for a few different things, and that's where the system kind of breaks down. But we also have mucus on all of those surfaces. So think about all those surfaces. You've got your nose, you've got your ears, you've got your mouth. Every single surface has what's called a mucous membrane. And if it's open, it's going to be wet and sticky. And part of that is grabbing those bacteria or whatever is going to come in to try to actually expel them before they enter the system. So that's line 1 of defense. Now, physical reactions can actually help with that. So coughing, blinking, and I think there's a video about sneezing, and there's our sneezing video that also appears in our note. So body fluids are washed away and trapped. They wash away trapped particles that cleanse the skin. So we can now go from that physical into a chemical barrier. Very similar in that we do have a physical element of washing that away. There is a bit of a difference between those 2. Right? Some of these fluids can kill or hinder bacteria after entering the body. So in this case, we've got tears and we've got saliva as well. So I want you to try to explain the difference between those things that are considered physical barriers like mucus or earwax or something, and compare them to chemical defenses. What's the difference there? All right, our second line of defense are our cellular barriers. Don't forget, we're still not in that specific. We're still in that overall very non-specific line of defense there, but we're now into the cells. So that means a pathogen has entered our system. It's gotten past those physical and chemical barriers to start with. Inflammation is our most important general non-specific line of defense. When microbes pass through our first line, our physical and chemical ones, our internal ones have to kick in. Okay, inflammation does appear, and it means the body's defenses are working. So in this case, just a little scratch, and you can see immediately that there's some signs there that inflammation is working. And here, someone's actually voluntarily gone and got what looks like a terrible tattoo, and their body is reacting to that because what they're doing is pushing ink into the skin. So we're trying to get past that the physical defense that is the skin, when really it shouldn't be. 5 signs of inflammation: heat, pain, redness, swelling, and loss of function, right? They're the 5. You can see that this particular one, there'd be a bit of pain there. There's absolutely redness. I imagine it's a bit swollen. You can see it's getting a bit raised there. I imagine, there is a bit of loss of function, but in this particular case, not so much. And you know yourself, and when you have something that's painful, it's probably a bit hot too as that blood flow goes to the area. Inflammation is all about the white blood cells. We know a little bit about them already. And what happens is damaged cells, so if you've cut your skin open, damaged cells release chemicals, and they actually trigger those white blood cells to come in and say, hey, we're over here, there's a problem here, clean up aisle 5, come over. The white blood cells destroy those foreign particles. Pus is formed from dead cells. Now, that might be your own dead cells, it might be dead cells of the bacteria or whatever it is cleaning up. So those white blood cells are, ranging in skill sets. Okay, we've talked about ones that engulf bacteria, but there also are other ones that can do a lot of other jobs. Neutrophils attack the foreign cells and the proteins, so those antigens are really what they're looking for. We also have natural killer cells, which can attack virus-infected cells. Now, when a virus does enter that cell, what it can do is kind of stick a little flag up and have a little antigen on the outside of that surface. It kind of plants its flag in that cell and says, hey, I've taken over this land. And it does that. And even though it's kind of skating under the radar, those white blood cells that are scanning through those blood systems can find those cells. Right, our monocytes are found in our blood. They are another type of white blood cell we know, and they can migrate into tissues. So they are the ones that are able to pass out of those blood vessels through the thin walls and jump out into tissues if need be. And they're the ones that can then go through that. We've seen this video where it does chase around the bacteria in the blood cells. Right, inflammation is all about the lymph system, and the lymph system is trying to remove dead cells before they get to that bloodstream. Now, you often find, you've got your lymph nodes in your neck, you've also got some in your groin and under your arms and things like that. And you often find lymph fluid is what happens when, say, you keep your arms by your side for a while, your hands will start to swell up. If you dangle your legs over something, they're going to start to swell up, and that's what happens. Because that lymph tissue is starting to accumulate. A lot of older people who don't get up and walk around a lot of that lymph fluid is pooling at the bottom of their feet. Your glands will fill with fluid for filtering, while your spleen is filtering out your blood. Now, your spleen can filter out chewed up, broken up red blood cells. It can clean up everything else that's not meant to be there as well. So those survivors are sifted out. And we often have parents that check for our glands to see if they're a bit swollen, to see if we're under the pump or our immune system is kicking in. Right, what I want you to do is suggest why skin and blood were the first tissues of which scientists develop transplants.